The Second World War transformed aerial combat from the gentlemanly duels of the Great War into a brutal contest of industrial might and technological innovation. These aircraft were more than machines. They were pivotal in shaping the outcomes of key campaigns. Supermarine Spitfire. The Supermarine Spitfire's story begins not with grand military strategy, but with a seaplane designer's obsession with speed. Reginald Mitchell had spent the 1920s and 30s crafting racing floatplanes that dominated the Schneider Trophy races. When the Air Ministry called for a new fighter in 1934, Mitchell essentially took his racing experience and strapped guns to it. The first prototype flew on March 5, 1936, with test pilot Joseph Mutt Summers declaring, "I don't want anything touched." By 1940, during the Battle of Britain, Mitchell's creation had evolved into everything Britain needed: grace, under pressure, and deadly efficiency. The Spitfire's Rolls-Royce Merlin engine produced up to 1,700 horsepower, driving variants like the Mark 9 to 408 miles per hour at 25,000 feet. RAF pilots engaged enemy fighters with either 8-303 Browning machine guns or cannon armament, while the revolutionary elliptical wing design gave it unmatched maneuverability that German pilots learned to respect. What made the Spitfire legendary was its ability to be continuously improved throughout the war. From the early Mark I to the final Mark 24 that served into the jet age. In the Battle of Britain, RAF squadrons, flying Spitfires and Hurricanes, achieved kill ratios near 2-to-1 against Luftwaffe squadrons, convincing German planners that Operation Sea Lion was unfeasible while the RAF held British airspace. Messerschmitt Bf 109. The 109's origins trace back to a fierce competition in 1933 between Germany's top aircraft manufacturers. Willy Messerschmitt was actually the underdog in this contest, his company known more for light aircraft and gliders than military fighters. But Messerschmitt had something they didn't: an obsession with aerodynamic efficiency that bordered on the fanatical. The first 109 prototype flew on May 29, 1935, powered by a British Rolls-Royce Kestrel engine because German engines weren't ready yet. By September 1, 1939, when German forces launched operations in Poland, Messerschmitt's creation had become the backbone of the Luftwaffe. The 109's Daimler-Benz engines evolved throughout the war, producing 1,475 horsepower and driving later variants to 386 miles per hour at 22,000 feet. The inverted V12 engine was a marvel of German precision manufacturing, featuring direct fuel injection that allowed it to maintain power during negative G maneuvers that would starve carbureted engines. This gave German pilots a crucial advantage during the opening phases of aerial combat, where the ability to push the nose down and dive away could mean survival. Luftwaffe pilots engaged enemy fighters using a 20mm MG-151 cannon mounted in the propeller hub and two 13mm MG-131 machine guns positioned above the engine. The centrally mounted weapons eliminated convergence problems that plagued wing-mounted guns, allowing Luftwaffe pilots to achieve hits at longer ranges with precision. The 109 featured automatic leading-edge slats that deployed during high G turns to prevent stalling. These slats created a distinctive rumbling sound that enemy fighters could hear, effectively announcing their presence. P-51 Mustang. The Mustang's creation story reads like a Hollywood script about impossible deadlines and last-minute heroics. In April 1940, the British Purchasing Commission approached North American Aviation with a desperate request. Britain needed fighters, and they needed them fast. On October 26, 1940, test pilot Vance Breeze lifted the first prototype into the California sky, beating their impossible deadline by 3 days. The early Mustangs, powered by Allison engines, were decent aircraft, but nothing revolutionary. The transformation came when someone had the brilliant idea to mate the American airframe with a British Rolls-Royce Merlin engine. The result was aviation alchemy, an aircraft that represented American industrial might, combined with British ingenuity, creating what many consider the finest fighter aircraft of World War II. The Mustang's Packard engine, a license-built Rolls-Royce Merlin, produced almost 1,500 horsepower and gave the fighter a top speed of 437 miles per hour at 25,000 feet. Speed wasn't the Mustang's revolutionary characteristic, it was range. With internal fuel and drop tanks, the P-51 could fly over 1,650 miles, finally giving the 8th Air Force the escort fighter they desperately needed for long-range missions into enemy territory. U.S. AAF pilots engaged enemy fighters with 6 50-caliber M2 Browning machine guns, carrying 1,880 to 2,000 rounds total. The psychological impact of long-range escort was profound. Luftwaffe pilots faced relentless challenges, unable to attack bomber formations without fighting through Mustang escorts first. Focke-Wulf 190. The 190's development began with a radical premise that challenged conventional fighter design wisdom. In 1937, when every major air force was committed to liquid-cooled inline engines for their fighters, Kurt Tank at Focke-Wulf decided to build a fighter around the heaviest, most powerful radial engine available. Tank's reasoning was pure engineering pragmatism. Liquid-cooled engines required complex cooling systems, while a radial engine was essentially bulletproof. The first 190 prototype flew on June 1, 1939. By September 1941, when the first production aircraft appeared over the English Channel, it surprised RAF pilots who had grown accustomed to outperforming the 109. The 190's BMW radial engine produced 1,700 horsepower, driving the fighter to over 408 miles per hour at 20,000 feet. The radial engine configuration provided several advantages. It was less vulnerable to battle damage, required less maintenance, and provided better forward visibility. Luftwaffe pilots engaged enemy fighters with two 20mm MG-151 cannons, two 20mm MG-FF cannons, and two 13mm MG-131 machine guns, creating one of the heaviest fighter armaments of the war. What set the 190 apart was its excellent roll rate and diving performance. RAF Fighter Command was forced to develop new tactics and eventually new aircraft to counter this new threat. Republic P-47 Thunderbolt. The P-47 Thunderbolt's origins lie in the fevered imagination of Alexander Kartveli, a Russian émigré who believed future fighters would need to operate at extreme altitudes. His solution was characteristically American: build the biggest, heaviest, most powerful fighter possible. The first XP-47B prototype flew on May 6, 1941, weighing nearly twice as much as contemporary fighters. Test pilots initially nicknamed it the Flying Milk Jug due to its portly appearance, though they quickly learned to respect its striking high-altitude performance. The P-47's Pratt & Whitney 2800 Double Wasp produced 2,000 horsepower, peaking at 2,500 with water injection, driving the fighter to 433 miles per hour at 30,000 feet. The massive turbo supercharger system maintained full power at extreme altitudes where many fighters struggled. USAAF pilots engaged enemy fighters with 850 caliber M2 Browning machine guns, each carrying 425 rounds for a total of 3,400 rounds. The P-47 could dive at speeds approaching 450 to 480 miles per hour, gaining tactical advantages during high-speed attacks. Mitsubishi A6M0. The Zero's development reflected the Imperial Japanese Navy's unique strategic situation. They needed fighters capable of operating over vast ocean distances. In 1937, the Navy issued requirements that seemed impossible. A fighter that could fly over 1,200 miles, outmaneuver any existing aircraft, and still carry meaningful armament. Jiro Horikoshi achieved these contradictory requirements through radical weight reduction that eliminated every ounce that wasn't absolutely essential. The first Zero prototype flew on April 1, 1939. When Zeros entered combat in the Pacific Theater in December 1941, they represented a triumph of extreme maneuverability and range, even at the cost of pilot protection. The Zero's Nakajima NK-1F Sakai engine produced 1,130 horsepower in later variants, giving the fighter a top speed of 350 miles per hour. At 20,000 feet, the Zero weighed only 5,313 pounds loaded, making it one of the lightest major fighters of the war. This extreme weight reduction was achieved through minimizing structural strength and eliminating armor protection. Navy pilots engaged Allied fighters with two 20mm Type 99 cannons and two 7.7mm machine guns. The Zero's legendary maneuverability came from its low wing loading, but its greatest weakness was its lack of protection for pilot and fuel systems. Hawker Hurricane. The Hurricane's story begins with Sidney Camp, a designer who believed in evolutionary rather than revolutionary aircraft development. In 1933, Cam took his proven Hawker Fury biplane design and methodically transformed it into a modern monoplane fighter. The Hurricane used traditional construction methods that could be handled by furniture makers and coach builders, spreading production across Britain's entire manufacturing base. By July 1940, Hurricane squadrons formed the backbone of Fighter Command's defense, representing the forgotten hero of the Battle of Britain. The Hurricane's Rolls-Royce Merlin engine produced 1,030 horsepower in early variants, pushing the fighter to 328 miles per hour at 20,000 feet. While slower than contemporary fighters, the Hurricane possessed handling characteristics that made it an exceptional gun platform, particularly against large bomber formations. RAF pilots engaged enemy aircraft with 8 .303 Browning machine guns, each carrying 330 rounds for a total of 2,600 rounds. What distinguished the Hurricane was its role as the primary bomber-destroyer during the Battle of Britain, with Hurricane squadrons concentrating on the bombers themselves, while Spitfires often engaged enemy fighter escorts. Vought F-4U Corsair. The Corsair's development began with the U.S. Navy's 1938 request for the fastest, most powerful carrier fighter possible. Vaught's response was to build an aircraft around the massive Pratt & Whitney R2800 double Wasp engine. The problem was that this engine required an enormous propeller, which created ground clearance issues. Rex Beisel solved this with the distinctive inverted gull wing that became the Corsair's trademark. The first prototype flew on May 29, 1940, immediately setting an unofficial speed record by exceeding 400 miles per hour in level flight. The Corsair's engine produced 2,100 horsepower, peaking at over 2,400 with water injection. The plane could accelerate to 446 miles per hour at 26,000 feet, making it one of the fastest piston engine fighters ever built. Navy and Marine pilots engaged enemy fighters with 6 50 caliber M2 Browning machine guns, each carrying 400 rounds for extended combat capability. The Corsair's distinctive sound became a psychological weapon in itself, known as whistling death to ground forces. Marine Corsair squadrons developed tactics that exploited their aircraft's superior speed and diving performance while avoiding turning fights where lighter fighters held advantages. Yakovlev Yak-3. The Yak's development reflects the desperate situation facing the Soviet Union in 1941. Alexander Yakovlev's design bureau focused on creating the lightest, most maneuverable fighter possible, using whatever materials and manufacturing capabilities survived wartime disruptions. The Yak first flew in October 1943, representing the culmination of hard-won combat experience and Soviet engineering pragmatism. When Yaks first appeared over the Kursk salient later that year, they embodied the Soviet response to Luftwaffe fighters, trusting in pilot skill and superior low-altitude maneuverability. The Yak's Klimov VK-105 engine produced 1,240 horsepower, driving the fighter to 407 miles per hour at 16,400 feet. The engine was specifically optimized for low and medium-altitude performance, where most Eastern Front combat occurred. Soviet pilots engaged enemy fighters with a 20mm cannon and two 12.7mm machine guns. The Yak weighed only 5,800 pounds loaded, making it significantly lighter than many contemporary fighters. This weight advantage translated into exceptional maneuverability and climb performance, completing a full 360-degree turn in 17 seconds. Curtiss P-40 Warhawk. The P-40 Warhawk story is one of making the best of what you have, when what you have isn't quite good enough. In 1937, Curtiss took their existing P-36 Hawk design and attempted to modernize it by installing the new Allison V-1710 liquid-cooled engine. The first Warhawk flew on October 14, 1938, and by December 7, 1941, Warhawks formed the backbone of American fighter defenses, despite being outclassed by more modern opponents. The Warhawk's Packard Merlin engine produced 1,300 horsepower, driving the fighter to 364 miles per hour at 20,000 feet. U.S. AAF and Allied pilots engaged enemy fighters with 6 50 caliber M2 Browning machine guns, totaling up to 1,800 rounds. The P-40 featured robust construction that could absorb significant battle damage, becoming legendary among pilots who flew it in harsh conditions. Flying Tiger pilots in China developed boom and zoom tactics that exploited the P-40's superior diving speed and structural strength while avoiding turning fights, where lighter fighters held decisive advantages. World War II represented the transition from mechanical to electronic warfare in fighter aircraft. Early warfighters featured simple mechanical systems. By 1945, advanced fighters incorporated radar systems, electronic navigation aids, and sophisticated fire control systems. The development of high-octane aviation fuel transformed fighter performance throughout the war. Early fighters used 87-octane fuel, but the introduction of 100-octane fuel allowed dramatic power increases from the same basic engine designs. The fighters of World War II embody the technological innovation, industrial capacity, and human courage that determined the outcome of history's greatest conflict. The lessons learned from their intense dogfights, long-range escort missions, and pivotal carrier battles continue to influence fighter design and pilot tactics in the 21st century. Thanks for joining this deep dive into World War II fighter aircraft. Don't forget to like and subscribe, and check out our other videos for more aviation history content.